Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome to FYI. I'm Tasha Keeney, an analyst here at ARC. Today we'll be talking about 3D printing. If you like this podcast and would like to subscribe, please do so. And if you want to hear more about 3D printing and our other research areas, please go to arc-invest.com. Today I'm joined by Peter Leys, chairman of Materialise. Materialise is a 3D printing firm that specializes in software and solutions for 3D printing for the medical and manufacturing space. Materialise Build Processor is one of the most commonly used pieces of software across many different 3D printing manufacturers. And Peter himself has been with the company since 2013. Previously, he was a corporate finance partner at Baker & McKinsey. And look forward to speaking to him today. Let's just dive right in. Thanks for joining us today, Peter. I'd love to hear a little bit about your background and how you got started in 3D printing. But first, a quick disclosure for our audience. ARC is an investor in Materialise. As of the end of April, we held about 5.3% of Materialise's shares outstanding. All right, now that's out of the way. Go ahead, Peter.
Well, as you may or may not know, Tasha, I joined the company in 2013, almost 6 years ago. Actually, I knew the company since 1997. I was an outside advisor to the company, so I knew Frit and the management team pretty well. Actually helped them support the growth of the company throughout. Various milestones of the company I was involved. And in 2012, 2013, we engaged in discussions, Frit, the management team, and myself, about where we want to take this company in the next 10 to 20 years. And throughout these discussions, the suggestion came that I, with my corporate background, that I would not only join the board, but also would join the management team and help the team and help the company as a whole to actually make itself ready for the next phase. So I joined in 2013. I left the bar, started to working full-time for Materialise. And this kind of, if you want, culminated in the company's IPO roughly 1 year later. We went to the NASDAQ in 2014 after investigating and actually eliminating a number of other possibilities. We concluded that the IPO would best fit our build-to-last philosophy of really building a company that would become a cornerstone or remain the cornerstone of the industry as this industry would be growing. And after a successful IPO, I think we've been executing on the strategy rather well.
Yeah, so let's talk about I think most of our listeners have heard of 3D printing, but maybe it'd be helpful if you could give sort of just a quick background. What is it, and how have you seen the technology in the industry evolve? Because this is something that the technology itself has been around for a while, but we might sort of be in this pivotal time.
The technology, indeed. The technology has been around, as you know, since the early 80s, patents being filed somewhere between 81 and 87, 88. Materialise was then founded in 1990. The technology is called 3D printing, and 3D printing is a horrible world, as you know, because milling is also in 3D, casting is also in 3D, so there the word 3D doesn't add much. Yeah. And then printing makes you think of 2D, printing books and the like. And it's only the combination between 3D and printing that kind of makes it a sexy marketing term. We here at Materialise, we definitely prefer the term additive manufacturing. First and foremost, because it talks about manufacturing, which is what it really is. And secondly, because it talks about additive, and additive actually distinguishes this manufacturing technology from the two other more mainstream manufacturing technologies, i.e. subtractive manufacturing and transformative manufacturing. Subtractive, you take a block of titanium, you chip away material, and at the end of the day, you have the gearing wheel that you always wanted. Transformative, I make a mold of a gearing wheel, I pour the heated liquid or the liquid steel into the mold. The liquid transforms, takes the form of the mold, and I have a gearing wheel. What do we do with additive? We basically do it the other way around. We will build the gearing wheel layer by layer. There's 2 or 3 main distinguishing elements that really distinguish additive manufacturing from the more traditional subtractive or transformative ways of making things. One, and a very important one, is the quote-unquote reduced cost of complexity. Complexity comes at a cost. You can make an extremely complex gearing wheel, and at a certain point in time, when you mill it or when you want to cast it, you will find yourself in a situation where actually you have to cut the design in 7, 8, or 20 different pieces, mill or cast those 7, 8, or 20 different pieces, and then assemble them. Which means that if your part becomes very complex, the cost of subtractive or transformative manufacturing also becomes high. With additive, whether I am building layer by layer a very straightforward box or a very complex gearing wheel, cost basically remains the same. So in other words, I can make very complex parts without adding much to the production costs. As a result, freedom of design. The designers can start adding functionality to the products that before they were not able to do so because the production methodology would not allow them to actually produce those parts. Reduced cost of complexity is one, which of course means that it's a technology that will be more apt for the production of complex parts than for more straightforward parts. Second, very important and very attractive, especially if you combine it with the first advantage, is the reduced cost of variety. If I want to make 16 different hip implants, because I want those hip implants to be personalized for 16 different patients, if I want to do it by casting, I will have to make 16 different molds, which just makes the process overly cumbersome, much too long in time, and overly expensive. If I instruct the printer to print 16 different implants, each and every one of them being personalized to a specific morphology of a specific patient, the printer will just rock along and the production cost will not change whatsoever. And at the end of the day, I will just take my 16 different personalized hip implants from the printer. The third distinguishing factor of 3D printing is the quote-unquote short time to market. So for prototypes, for a first off, a 3D printer allows me to just short time to market, to overnight produce in reality, to materialize, if you want, a first off, a prototype of a certain part, which I will then probably send to a more complex production line once I decided to industrialize it. 3D printing was, as we said earlier, was created in the 80s, and in the 80s, but also in the 90s, and even still today, 3D printing is used, because of its short time to market, is used as a rapid prototyping technology. What makes it now exciting, this market, is that nowadays people are starting to recognize that also that reduced cost of complexity and that reduced cost of variety are also very important distinguishing elements that actually allow you to use the technology not only to just print prototypes, but to actually go ahead and produce complex and or personalized end parts. Obviously, the market for complex end parts, the market for personalized goods is huge and is significantly higher, bigger than the already mature and existing market of making prototypes. And that is what makes this technology so attractive and so exciting today in 2019. It's the aviation industry that is looking for production methodologies to make much more complex parts. It's the medical industry that is looking for ways to introduce personalization in the dental market, in the hearing aid market, in the craniomaxillofacial market, in the cardiovascular market. It is the shoewear market, the eyewear market, that is wondering to what extent they can actually add value for their customers by using this additive manufacturing technology to offer their customers personalized shoewear, personalized eyewear. What we are doing, together with some other players in the industry, is already looking for solutions that actually seek for enhancements. While we see all kinds of meaningful applications growing, while we co-create new meaningful applications with customers, we simultaneously introduce new functionality in our software suite that actually will help increase the productivity of the technology. And I see as machines will become more productive, and that's going to be a joint collaboration between machine vendors, between material vendors, between software manufacturers. As the whole ecosystem is collaborating and working strongly together to make the machines more effective and productive, that will open the potential for more meaningful applications.
Right.
And as the market is looking for more and more meaningful applications, it will actually make the market more attractive for material vendors and machine vendors to actually step into the market. And that's what we see today. I mean, it's not a surprise that parties like an HP or like a BASF have actually discovered this market only less than 3 to 5 years ago. Why is that? It's not because the sole rapid prototyping application was of interest to them. It's because they see that their customers actually are working on those meaningful applications in huge markets such as aviation, automotive, footwear, eyewear. And it's because they also believe that there's quite a bit of work that can be done to make that production technology much more effective, much more productive.
You know, that's a great overview. And here at ARC, we're big believers in 3D printing. You know, you talked a little bit about 3D printing started off in sort of prototyping, but now we're seeing it being used in end use parts like in healthcare and aerospace. You know, I'd love to sort of get your perspective on how you think the investment world sort of looks at this technology, and sort of since, Materialise has gone public, what have you seen in the market? Do you think that there's something that investors are misunderstanding? I mean, we had this sort of hype phase in 3D printing where everyone was believing in the personal 3D printer, and that never materialized. You know, we don't think it ever will. That's not the story of 3D printing. But what's happening today in sort of the investor world, and do you think that people are getting the story right?
I think that people are getting the story more and more. Frankly, I understand it's fairly easy when you dig into the value of the technology to understand and to forecast for yourself that this is a technology that is not only here to stay, but that this is a technology that will be more and more widely adopted because the advantages are so clear. Obviously, what the investor wants to do, the investor wants to understand where the value that will be created by the industry-wide adoption of that technology, where it will fall. Because, of course, that's where the investor wants to be, is my best guess. With this new ecosystem that is shaping, I can understand that is not an easy question to anticipate on, because there's so many players in the ecosystem. There's people who make the machines, there's people who sell the machines, there's people who make the material, there's people who actually, subcontractors who will use those machines for their customers. There's OEMs that will actually are currently involved in creating those new applications and will bring those applications to the market. They will all use that and embrace that new technology. But the question is, who will make most advantage from the adoption of that new technology? Is it the material vendor? Is it the machine vendor? Is it the software provider? Is it going to be the medical device company? Is it going to be the OEM in the automotive industry? Is it going to be the large contract manufacturers? And my guess is that is one of the questions that investors are currently working on and struggling on. Yes, I'm convinced that this is a technology that has a bright future, but where is the value that is going to be generated by that technology? Where am I going to recognize it? That is not an easy question to answer, especially because this ecosystem is still shaping up.
But one of the things that I think is so amazing about 3D printing is not just this sort of complexities-free idea where you remove all these barriers to design, but also there are a lot of cost advantages to the technology. I guess could you run through maybe an example of where 3D printing was able to perhaps reduce complexity, but also sort of make a difference on the cost side? Because we think that's when companies need to, basically when companies are in distress and they need to cut costs, that this could be one of the first technologies that they look to in order to do that, in order to make that change.
Yes, it's a good question. And I didn't want to suggest that currently no complex parts are being made, and that suddenly with 3D printing, we open the potential for producing complex parts. complex parts, of course, today are being produced. And a typical example is the GE fuel nozzle, which is a horribly complex part. It consists of, I forgot the number, I think it's 30 plus different parts that are all being milled and subsequently being assembled in a very complex and highly regulated assembly welding process. With 3D printing, we are now able to 3D print that part in one go. Now, if you compare the cost of 3D printing the entire fuel nozzle in one go with the cost of first designing the fuel nozzle, then designing 32 different parts, then defining the production process for the 32 different parts, executing that, then designing the assembly process to bring them all together, executing the assembly process. If you compare those two processes, then clearly, and that's also the conclusion that GE has drawn already a couple of years ago, 3D printing the part in one go, quote unquote, the same part, with at the end of the day, not that many design changes, is just significantly cheaper in terms of money spent, but also in time of hours spent, so also more effective than applying the more traditional production technology, which is just much more time-consuming and much more complex, both from a design and from an execution perspective.
Right. Yeah. And sort of what do you see as the future? There's a lot of opportunities in healthcare, as we've talked about this example in the past of how hearing aids, they're very tailored to the user. And now today, most hearing aids are 3D printed. What do you see as sort of greenfield opportunities in the 3D printing space where we can sort of see, okay, this makes complete sense for the manufacturing technology to switch over to additive manufacturing?
I think when we can stay in the medical field, maybe we should do that first and then move on to other areas. In the medical field, yes, I think the hearing aids is a perfect example. I think in less than 500 days, the entire industry switched from traditional milling to actually almost 100% 3D printing hearing aids, at least in the US market. The second market that actually has embraced 3D printing significantly is the dental market, where many of the crowns and the bridges are currently they need to be customized, are currently being 3D printed. So that is clearly a market with huge potential, where you see companies like Align, and the next step will be companies like Smile Direct actually adopting that technology and bringing it to the market in huge volumes, all through the exclusive use of the 3D printing technology. So it's an example that's going to be even more huger than the hearing aids market, if you want. Taking it further, definitely orthopedics market, but and even more logically craniomaxillofacial, because using a standard implant to quote unquote fix a unique face is just an inherent contradiction, a contradiction that simply is unacceptable for the patient. Those are clear markets that are adopting and are embracing 3D printing more and more. If you look outside of medical, or outside of medical in the strict sense of the words, the shoe-wear market, we genuinely believe is also a market. And if we see what's going on in the market, if we see which players are actually significantly looking at using the technology to customize shoe-wear, the shoe-wear market is also a market that we believe will much sooner rather than later embrace the technology fully, because customization there, again, makes a lot of sense. Optimizing the supply chain also there makes a lot of sense, because you have this combination of optimizing your supply chain and adding significant value to the customer.
Let's talk a little bit about sort of Materialise's role in this future. As you've been at the company, sort of how have you seen the company grow, and sort of what do you expect for the coming years, and what are you most excited about?
What makes this company a unique company, and leaving the people aside, which of course make this company truly unique, but what makes it really unique is that the company has always been focusing on knowledge. We are selling knowledge. We are gathering knowledge about this new, exciting technology, and we want to share that knowledge with the world. Now, don't take me wrong. When I say share, I mean sell. And that's how you should look at Materialise. Mm-hmm. And how do we, so we see all these applications, and we constantly ask ourselves the question, how can we play a meaningful role by empowering those applications through the knowledge and experience that we've gained over the last 29, close to 30 years. That's the baseline. And how do we then strategically position the company to actually share our knowledge with the world, or to put it otherwise, monetize the knowledge that we have gathered? I'd say in two ways. We have this horizontal backbone, which is our Magix suite in the industrial software market. It's our Mimics suite in the medical market, that we believe are two software platforms that can be used by anybody who uses 3D printing, regardless for what application. The Magix can be used by anybody who uses a 3D printer, regardless for what application. Mimics can be used as a visualization and design tool for anybody who uses 3D printing in the medical field. So by developing those two platforms, very broad horizontal platforms, and by constantly enhancing them, by including the new experience that we learn as we work with medical device companies and with large OEMs, we want to be broad and be supporting as many applications as possible. But that's only one way to share knowledge. Secondly, we've also learned, as we talk to certain customers who come with certain questions, that we can just add much more value than just licensing a off-the-shelf software product, which will require us to co-create together with the customer, create IP, which will be our IP or which will be joint IP, and create customized software solutions that will actually help the customer to bring a new, innovative product offering to the market. And a perfect example of that is our collaboration with J&J in the CMF market. J&J does much more than just use our Mimics technology. Much more is used than just our Magix technology to 3D print those implants. We have a collaboration where our software tools are used to personalize the instruments that are being used by the surgeon, where our software tools are used to personalize the implants that will be used by the surgeons, whereby the surgeons are in direct contact with our clinical engineers to actually tweak the personalization of the implant to the perfect liking of the surgeon. Also, the order management system that actually allows us to make sure that the right instruments arrive at the right time at the right surgeon's desk is also a Materialise backbone. So there we collaborate with J&J and make sure that they have a full service offering that they can include in the portfolio of their sales force, which can then offer to the surgeons the standard portfolio of standard CMF products of Dubucintis J&J, strengthened and enhanced by personalized products that are branded as J&J products, but empowered by Materialise. So what we do is we want to serve the world, if you want, through our horizontal backbone of Magix and Mimics tools, and we are looking for a limited but well-identified number of verticals where we will typically partner with market leaders or strong believers in innovation in their market, where we will want to go deeper, capture a bigger part of the value chain, and actually also that way empower the parties to bring a new innovation to the market. That's how we try to position Materialise.
What do you see as sort of the biggest challenges today? What keeps you up at night?
There's two challenges. I wish there were only two challenges, but if you want, there's two challenges. One is timing, which is the biggest challenge with any innovation. We can spend a lot of time on adding, we have wonderful ideas. We can triple our Magix and Mimics suite with all kinds of functionalities that our customers are dreaming of. But the question is, should we do that? Is the market ready for it? And if the market's not ready for it, it's going to be lost R&D dollars.
Right.
But of course, we have to make sure that those suites stay on top of the market. So we have to innovate in tune with the rhythm of the market. Make sure that we're not too early, because those will be lost dollars. Make sure that we don't miss any opportunity, because of course, any opportunity that we miss is an opportunity for a competitor to come in. So timing is crucial. And there, frankly, 29 years of experience that the people at Materialise have help significantly, because it's much easier to spot an opportunity than to time the investment right. So that's always a concern. And whenever you decide to delay a project, you wake up at night and you wonder whether you should not fasten it up again, or vice versa. The second, even if I may say, even bigger challenge, obviously, is the war for talent. People who make the difference here at Materialise, I say over and over, we are selling knowledge. We are monetizing the knowledge that we've gathered. The knowledge, at the end of the day, yes, we have a portfolio of more than 200 granted and more than 200 pending patents. But a patent is just a patent. The knowledge, at the end of the day, sits and lies in the heads of our people. So the biggest challenge for our growth is to make sure that we keep the wonderful people that we have on board and that we remain a very attractive company to attract new talent. Your next question will undoubtedly be, how do you do that?
Right.
I will disclose it to you, being fully aware that the competition is probably listening. It's our culture. It's our culture, and that's why I feel free to disclose it, because it's something that nobody can copy. It's really it's the culture that has been created by our founder in the early 90s, and that is that perfect mix between a drive for technological innovation, but really inspired by this absolute conviction that this technology will make the world a better and healthier place. And when I talked about the advantages and how the ecosystem can, from an economical perspective, become better, obviously, if it is better from an economical perspective and sustainable, that means that it's also better from an ecological perspective. We are making the lives of many, many patients better. By optimizing supply chains, we are reducing the pressure of our current system on the limited resources that the planet has. And when you've been here, you can feel the people are here for those two reasons. And I'm sure there's a third, that's salary, but that's something that competition can copy or can even beat. But those two two other elements are very crucial. And they're here in a very authentic way because they've been lived by people who've been around for 30 years.
And as you've been at the company and sort of seen, this journey progress, is there anything that's really surprised you where you said, wow, I knew that additive manufacturing was sort of capable of creating something new, but I didn't expect this to happen, or, I didn't expect this to be the outcome. And then I guess is a twofold question. Often with innovation, we find that what you're capable of doing, because you're sort of creating things that were never even before possible, that it's actually kind of hard to predict what will the future look like, because it's sort of nothing like you could imagine today. So I guess, have you seen sort of past examples of that? And do you have any ideas of what 3D printing could do that will sort of surprise us all in the future?
Yeah, when I made the switch, to a large extent inspired by the culture that I just described to you. But I'm surprised almost on a daily basis as how real this dream could possibly be and how close we are to actually contributing to the realization of the dream. And let me just picture you the dream. And this is a dream. And maybe I should read all the investor caveats that are typically read at a quarterly call, because who knows when this will materialize, and if so, if it will materialize, and if so, when. But this is a technology that, if we do it right and if we find the right partners, that will actually allow us to change the economy from a product-centric economy to a genuine consumer/patient-centric economy, where it is not the consumer or the patient walking into this store, which at the end of the day is a warehouse of standard products, trying to find out what he or she likes best, and in many instances actually being some standard product imposed upon by a smart vendor. We are actually completely changing the paradigm here, where the patient or the consumer is central and says, I want something that is unique, that fits my needs, but literally, that fits my body, that fits my tastes, that fits whatever I want. So I don't care what products are available. I will tell you what I want. I will give you the quote-unquote design. That's full creativity. That's the creativity of the individual. And only when I am satisfied with the design, only then should it be produced, which means perfect use of our resources. We will only use resources. We will only put resources to work at a time when the customer's individual needs have been well defined. And then we will produce, and we will produce as close as possible to the place where that consumer sits. That's a dream, and it's a dream that is not crazy enough to make you come back to work with a big smile every day, but is actually feasible. And if you think of what the people are doing here on a daily basis, and if you think of what deals we are discussing with all our partners, it's a dream that is not only shared by the collaborators here at Materialise, it's a dream that is more and more being shared by all the partners that we are currently engaging in. So I believe it's a dream that could be realized in a few decades or so, which would actually mean a significant paradigm shift.
I'd love to talk about sort of what that dynamic that you just described, the supply chain moving closer to, I guess it's sort of most ideal location or sort of closer to the end product. What are the most prominent examples of that? And what industries do you think are, sort of ripe to make that transition that maybe haven't done that yet?
A good example is hearing aids. We're hearing aids. We've actually seen this move in the direction of decentralization. Another market where this is definitely going to happen, obviously, is the spare parts market, where now we have a limited set of spare parts sitting in a warehouse somewhere. The airplane gets stuck at a certain airport. Another airplane has to go and get that part. It is just not an efficient way to actually organize the supply chain of spare parts. If we can create a virtual database of spare parts with very small production units, just a few printers that can handle a few different materials at places close to airports, that will be a way to actually service this spare parts market in a much more efficient way than what we are currently doing. Again, it's not for tomorrow, but it's something that we're working on today. Because what people are doing today is people are designing products today for 3D printing, or at least they are designing parts taking into account that even if we're going to mill them today, the large volumes, the design should be such that it can be 3D printed to serve the spare parts market. So that again is a clear example of how this technology, possibly in conjunction with traditional milling for the initial part, could eventually help to optimize the supply chain of the spare parts. Now that is not for tomorrow, for the simple reason that the parts that break today are parts that have been designed for milling or casting and cannot just simply be 3D printed. Otherwise, there would have been a metal 3D printer at every airport. So that will take a while, but it's the entire reorganization of the spare parts market is definitely one that you can realistically dream of will change over time.
Yeah, and on that point, the timing of this, so because 3D printing, often you have to change the design of what you were going to create, and maybe even have to sort of take another look at the whole structure, depending on, again, sort of what the application is. Do you think that the investment community now has a good sense of what the timing of this adoption is? Do you feel like your customers and the companies that you work with sort of have a good sense, or is it, sort of a case by case situation in terms of how 3D printing gets integrated into a new process, and sort of what are the dynamics of that?
Fried talks about the slow revolution, and I think he's very right. Although neither our marketing department nor our investor relations department were particularly keen on him using the term slow revolution, because we viewed that it would probably not be well received. But we have this tendency of being transparent and fairly open in what we think, where we think the market goes to. It is a slow revolution if you look at it as a whole, and it's going to happen on a case by case basis. And because it's so disruptive, because it requires you to really rethink your entire supply chain, or because, for instance, for medical, it requires the regulator to rethink his approval process. Because where in the past you cleared a standard product, now you have to clear a production process, because every product will, by definition, would have to be different. So there's quite a few barriers that you have to take. So by definition, I would say it is going to be, overall, as a market as a whole, it's going to be slow. The great thing is it's slow, but it's happening. It's not slow in the sense of you may have to wait for another 3 or 5 or 7 years. It's happening today. So for the investor, but that's your job, not mine, because it's happening today and slow overall, that means that there's opportunities out there in the market where it's going to happen fast. Not overall, but the average consists of small events and events that take place now and events that will take place in 3 or 4 years. So for somebody who digs into the industry and who gets a good understanding of the applications, I'm convinced that there's investment opportunities out there where you actually will sit together with the fast movers directly or indirectly. Materialise would be more indirectly, and actually be at the forefront of that slow revolution. And then there's, on the fairly short term, I would suspect interesting growth potential to be taken. But the challenge will be for the investors, but it's also a challenge for us to identify those applications that you believe will move sooner rather than later. But overall, the adoption by the entire market, that is going to take place gradually, I would say, over the next 1 to 10 years.
Right. Okay, great. And, my last question is there a message that you'd like to leave our listeners with?
My message would be share the dream. Think of what's going wrong in our ecosystem now. If you have a good understanding of what 3D printing can actually do, if you share the dream, and then find those players in the ecosystem that will actually materialize that dream sooner than their concurrents in the market. And then you should be part of the winning teams.
Thanks so much for joining us today, Peter.
My pleasure. Thank you for inviting us.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions, and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.